To truly evaluate video generation models as world simulators, we must look beyond visual quality to how the depicted world reacts to actions. This concept is called inherent reactivity. When a character moves, the environment should adapt naturally without explicit instructions. For example, if a character walks upstairs, their height must adapt to the terrain. WorldExam is a new diagnostic benchmark designed to test this capability across 1,474 test cases, evaluating whether generated worlds react plausibly to user controls. Existing benchmarks fail to test a model's understanding of implicit physical and social rules. Currently, benchmarks only check if a model fulfills explicit instructions, like executing a specific camera pan. They do not evaluate unstated consequences, such as whether a character collides with an obstacle or clips through it. This leaves a model's true physical common sense completely unexamined, meaning high visual quality often masks a complete lack of physical consistency. WorldExam solves this by organizing evaluation into a structured, four-level diagnostic hierarchy. First, visual quality measures basic perceptual plausibility and temporal stability. Second, control adherence checks if the camera or subject follows input commands. Third, spatial consistency evaluates if the model preserves the scene when revisiting a viewpoint. Finally, world reactivity tests scene-conditioned physical and social reactions, as well as goal-directed behaviors. To compare models fairly, WorldExam introduces a unified interface adaptation method. World models use diverse control interfaces, making direct comparison difficult. WorldExam represents controllable behaviors as atomic control units. It then maps these units to each model's native format, SE3, trajectories for camera-driven models, discrete actions for action-driven models, and natural language prompts for language-driven models. This allows a fair, head-to-head comparison of diverse architectures. Evaluating complex physical reactions requires a hybrid pipeline of 3D geometry reconstruction and vision-language model judges. For geometric tasks like terrain interaction, WorldExam lifts the generated video into 3D space to track height adaptation. For semantic tasks like object or social interaction, a VLM judge evaluates the video against case-specific checklists. This ensures that reactions like object deformation or pedestrian avoidance are verified systematically. Evaluating 20 representative models reveals a clear capability split across different model paradigms. Camera-driven models excel at camera control, but do not support dynamic interactions. Action-driven models control subjects precisely, but leave the surrounding environment unresponsive. Language-driven models handle interactions better, but struggle to follow complex, composed controls. No single model currently combines broad task coverage with strong reactivity. While highly effective, WorldExam has key limitations bounded by current model interfaces. First, dynamic interaction evaluation requires reliable third-person subject control, which many action-driven models currently lack. Second, the benchmark evaluates observable end-to-end behavior rather than verifying if the model has learned an internal causal representation of physics. Finally, goal completion tasks remain limited to language-driven models. WorldExam establishes a new paradigm for evaluating world models, pushing the community toward building truly reactive virtual environments. By shifting the focus from apparent appearance to inherent reactivity, this benchmark exposes the critical gaps in current video generation. The provided diagnostic tools will help researchers move beyond simple video clip generation, paving the way for persistent, physically consistent virtual worlds.